backed by popular demand, making a YouTube video, right? I know I haven't recorded in quite a long time, but this is how desperate the situation has gotten with inverse trig. It's a little bit scary. Yes? A class gaming channel, this guy. Anyway, in order to be successful with inverse trigonometry, there are unfortunately a couple of small things that you do just have to memorize. I know nobody likes to memorize. We want to know why things are. Trust me, for right now, memorize is our only option. And those things are the quadrants where our inverse trig is allowed to return values to us. When we are talking sine inverse, it can only return values in quadrant what I'm calling -1 and quadrant 1, like this. Why? Well, you'll understand why once we've done our graphing. For now, I need you to know sine inverse can only return values in one of those two quadrants. The cosine inverse can only return values in quadrants 1 and 2. At least we don't have to say anything ridiculous like quadrant -1 when we do this. So cosine inverse can only return values in quadrants 1 and 2. And as it turns out, not only is this where sine inverse is going to be, it's also where tangent inverse will be as well. We will not worry about the reciprocal inverse functions. Thank goodness. So when we're doing inverse trig, it will only be sine, cosine, and tangent inverse. For inverses, at least. Okay. So these things, at this point, just have to be memorized, and we're going to use these ideas. So when I'm going through the practice questions, I'm going to say things like, oh, and, well, sine can only return values in quadrant 1 and -1, right? And that's because we hopefully have these two pictures memorized. Before I get onto any of the examples, I want to show you something. Let's say, for some reason, we end up with an answer like this. Let's just say we got something like this. And for some reason, our answer ended up being this big angle. Let's just say it's a sine inverse question. Let's just, for the sake of argument, say it is. And I'll even do it in degrees. Okay, let's say for some reason we're talking about an angle of 300 degrees. And you go, there, my answer is 300 degrees, sine inverse told me so. And you go, no, it didn't. You see, sine inverse could never tell you 300 degrees because sine inverse could only tell you angles from 0 to 90 or from 0 to -90. So what would we do? Instead of calling this quadrant 4, we would call it quadrant -1, and we would call that a -60-degree angle. You see, they are coterminal angles, and that's one of the reasons why we study the idea of coterminal angles. So if you want to think about this quadrant -1 thing as being the coterminal quadrant to quadrant 4, how does that work? Can I say something like that? So if something for some reason landed in quadrant 4, we go, no. That's coterminal to quadrant -1. Okay? We good with those ideas? All right, then we can actually get to some practice. Start with this one here, cosine inverse of -√3/2. Remember, all trig inverse has outputs that are angles. And that is because regular trig uses angles as an input. So if it's an input on the original, it's an output on the inverse. So if the angle is the output, what that means is that these two numbers, this √3 and this 2, those are side lengths of a triangle. Cosine, and I know this is cosine inverse, cosine is negative when you have negative x's. The reason why is because cosine is x over r. So you think, well, there are two places where cosine can be negative. Two places where you have negative x values. Those would be on quadrants 2 and 3. But this is cosine inverse. It can only return answers from quadrant 1 and 2. Since 2 is the overlapping quadrant that I just mentioned, quadrant 2 is the only place I can draw this triangle. So I draw quadrant 2, because in quadrant 1, cosine would have been positive. And of course, picture not drawn to scale, nor is it straight. Go home x-axis, you're drunk. But we gotta do what we gotta do. Cosine is x over r, so that makes this root 3 negative root 3 here, and the radius is 2. Well, quick Pythagorean theorem or memorization of our special right triangles tells us this is a 1. So my question is, what is the reference angle in this triangle? It's a 30-degree reference angle. Because it's across from a 1, we know that this is a 30-degree reference angle. Oops, that says 300. 30-degree reference angle in there. But I want to answer in radians, so 30 degrees would be pi over 6 radians. This would be pi over 6 in here. This is pi. So what I have here is a line that is a whole pi over 6 before pi. So what would that be? 5 pi over 6. And if that wasn't perfectly clear, you talk to me. I'm sorry about the picture being scribbly the way it is. But you talk to me. You ask me a question. You let me help. Because we're not going to have another practice day. We just don't have time. Yes?
It's a little, again, I forget it.
Yeah.
What if that cosine of negative 1 is like
Cosine inverse? You mean what if it was,
cosine inverse?
yeah, we're going to do it. Okay. It's called composed. Composing trig and inverse trig.
So after you solve it, would you cosine of like 30 degrees?
Basically, yes. We're going to evaluate the inside and then work our way to the outside. Yes? I'm sorry? Yes, you scared me for a second. I had to double check. I was like, oh gosh, did I forget to hit record? No, I'm recording. You scared me. I know, I'm out of practice, right? Yes? Theta is out here. That is theta. Because our angles are always going to start at the positive x-axis, and then this is just the terminal side of our angle. So that's why we say, what's the reference angle that creates the triangle? Yes?
Can you go from the reference angle to 5 pi over 60? Like that's
How I did that? Sure. How about instead of calling it pi right there, since we know this is a pi over 6, why don't we make this in terms of sixths? Let's call it 6 pi over 6. So I just made it in terms of the denominator. So if this is 6 pi over 6, this is 1 pi over 6 before it. Good, 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 good. So let's hit up sine inverse of negative 1/2. Oh, yes. How do we get the reference angle? These would be from the two special right triangles, the 30, 60, 90, and the 45, 45, 90. Because this hypotenuse was a 2, and I knew the x value had to be a negative root 3, this forces a 1 right here. This forces a 30, 60, 90 triangle, and the 30 is always across from the 1. The 60, which is up here, is always across from the root 3. So this is sine inverse of negative 1/2.
Mr. McCutcheon,
Yes.
is it 5 pi over 6 because you're subtracting one of the pi's from the 6 pi over 6?
Yeah, that's basically why. It's like, I know I have to travel 6 of these things to get from here to here, and there's a gap of 1 right here, so I must have traveled 5 of them to get there.
Okay.
Or you could think of it as saying 6 pi over 6 minus pi over 6, if you'd like to.
Okay, thank you.
You're welcome. So sine inverse, like we talked about right before we started the lesson, sine inverse can only return values in quadrants 1 and negative 1. The fact that it's negative tells you instantly which of those two quadrants you must be in, because sine is y over r. It's telling you the y value is negative. Forces you into quadrant negative 1. I'm sorry? Well, for sine, yes. Yeah. And for tangent inverse as well. And if it's positive for all three, if the argument is positive, all three of them, you're in quadrant 1, which just makes life easy when it's positive on the inside. So let's draw ourselves a triangle, picture not drawn to scale as usual. Now, since I said sine, we know we're talking y over r. Our y value is the negative 1 then, because you cannot have a negative radius. That doesn't make any sense. This is a negative 1. And good old Pythagorean theorem or knowledge of special right triangles puts a root 3 here. Just like this question, I'm looking at this reference angle. It's across from a 1. Therefore, it is a 30-degree reference angle because it's across from the 1. But this is quadrant -1. This angle is opening this direction. That means you could legitimately say that theta is -30 degrees. But I want to use radians, so I'll say that theta is negative pi over 6. And then, of course, we pause for not only effect, but to see if there's any questions to let me help clear it up. No? Now, this next question is where first period came to a screeching halt. So we'll just throw that away, and we'll move on to this. And if anybody in first period is watching this video, I now know why it came to a screeching halt. It's because I made a boo-boo. So we don't do reciprocal inverse trig in this course. That is saved for AP Calculus. And that's why it didn't work quite right in first period. All right, so let's make this happen. Tangent inverse. Well, tangent inverse can only exist, well, its outputs can only exist in the exact same place that sine inverse does, and that's quadrants 1 or -1. Since this argument is negative, I am automatically going to be forced into quadrant, quote unquote, -1. But this needs to be a fraction. So let's say it's -√3 over 1. You see, tangent is y over x. And if you're in quadrant -1, which is like this, well then clearly the x is not the negative thing. So the x is the positive 1. Because it is y over x. Well, again, Pythagorean theorem or knowledge of special right triangles forces this to be a 30, 60, 90. I am sorry about all the 30, 60, 90 stuff, but let's be real, there's only 2 special right triangles, you know? What kind of reference angle is always across from a √3? A 60-degree angle of some sort. This must be a 60-degree angle, but because I'm in quadrant -1, you could actually call this negative 60 degrees or negative pi over 3 radians. And I like radians. Is it feeling a little bit better than it did yesterday? Okay, yes ma'am. Tangent inverse and sine inverse have the same output quadrants, yes. And when we do the graphing after the holiday break, I'll be able to show you exactly why that is, and you'll go, oh, and then it's less a trick of memorizing, you know, because then you understand why it worked, and then you understand why it was forced. But for now, I have to go. I'm sorry, memorize it. But after holiday break, I'll show you the graphs, and you'll see why it had to be the way it is. Cosine inverse of +1. This one's interesting. You know, the argument of the trig is supposed to be a fraction, right? So this says cosine inverse of 1 over 1. Well, cosine is supposed to be x over r. How is it possible that the x and the r are exactly the same length? Ah, it's one of the quadrantals. And more specifically, it's positive x. So I must be on the positive x-axis. You didn't have a choice. Puts you here. At 0. That's it. Theta equals 0. Because this is where x and r have the same length. 0 degrees or 0 radians, doesn't really matter, just pick one. I like radians. If we put what? Right here? You can't do this right here because what does x equal here? Oh, I'm sorry, you can do it here. It wouldn't be negative, it would be 0. Because x is 0 here, then you're going to have 0 over r at 90 degrees, which is just 0. And the same thing actually down here at negative 90 degrees. It's also 0 for the same reason because you have an x value of 0. Okay? So oh, look what I did. And nobody said it. And here it is on the YouTube video. Bet money someone's screaming at their monitor right now. My answer's not wrong. My picture is. Cosine inverse cannot exist in quadrant -4. I don't know what I was thinking. It goes from 0 to pi. And I wouldn't have caught it unless Lauren asked that question because I was like, wait a second, where would cosine inverse be -1? Crud, my picture's bad. Cosine would have been, cosine inverse is -1 over here. Because here you have a negative x value with still just r. It's still 0 here because x is still 0 here, yes. Sorry about the bad quadrantal picture, folks. I kind of got excited about how fast we got to the answer, so I drew a bad picture. Cosine inverse is quadrant 1 and 2. I swear I'm smart. Well, if you excuse me, I'm going to pick up what's left of my credibility and move on to the next question. This one does say sine inverse, and that one is for sure. Sine inverse is for sure quadrants 1 and -1. So I'm just going to go ahead and get it out of the way to draw it. But wait a second. Sine is 1. Sine is 1. Well, sine's y over r. So the only way it's possible that y and r are equal to each other, because this does say sine inverse of 1 over 1, is if, once again, I'm on one of the quadrantals. But where on these 3 lines that I've drawn would sine be positive 1? The top one, right here, pi over 2. Right here, I have a positive y value and, of course, a positive radius. So pi over 2. There. I'm sorry? Which one? Cosine inverse? Because cosine is x over r. That's the only reason why. Because cosine is x over r. In order for it to be equal, I needed to have a positive x value. Sine is y over r. So you need a positive y value, yes. Yes, sir. The question's asking, what does sine inverse of 1 equal? Trig inverse is always looking for an angle as its answer. Trigonometry, if I say what's sine of 30 degrees, see for standard trig, you're taking an angle, you're plugging in an angle, and then you're answering using sides of a triangle. Trig inverse does it in reverse. It takes sides of a triangle and tells you what angle would have produced that triangle. Let's see what's next. Time to compose. So this first question says cosine inverse of cosine. So the very first thing you want to do is go woot, inverses, and cancel them out, right? But no, you can't always do that. When can you do that? When you're in quadrant 1. But this is not in quadrant 1. This is outside of quadrant 1. So how do we do it? The guaranteed to get it right, but slow way is what I'm looking for you to do for now. Eventually, I'd like for you to get a little bit faster and learn the tricks. But for now, the guaranteed, I'm going to get this right way is evaluate the inside first. So let's see what cosine of 7 pi over 4 is. Well, 7 pi over 4 is almost 8 pi over 4. That's almost 2 pi. That puts me in quadrant 4. See, this would be 8 pi over 4. This would be 6 pi over 4. 3 pi over 2. Whoop, I wrote 2 because I said 2. There. So we draw our triangle. Now this is an over 4, so what kind of reference angle am I talking about? Yeah, this is a 45. So this is a 45, 45, 90 triangle, which is a 1, 1 root 2. So 1 here because it's positive x, but negative 1 here because it's in the 4th quadrant. And then here's your root 2. So what is cosine of 7 pi over 4? It's going to be x over r, which is 1 over root 2. So cosine of 7 pi over 4 equals 1 over root 2, which is root 2 over 2 for rationalizing denominators, but I don't want to. So what this question is now asking me to do is perform cosine inverse of 1 over root 2, because that's what the value of this is, 1 over root 2. So we say, what is cosine inverse of 1 over root 2? And this is where you go, okay, where's cosine inverse allowed to return values? It's only allowed to return values in quadrant 1 and quadrant 2. The fact that the argument is positive forces me into quadrant 1. Where the x is a 1 and the radius is a root 2, this forces a 1 here, which is, again, a 45, 45, 90, but it's actually a 45-degree angle is the answer. So it's pi over 4. So this whole thing, which originally we say equals theta because it's going to end with an inverse trig, which means I'm going to end with an angle. My theta is this angle, positive 45 degrees, also known as pi over 4. Now, just to prove a point, handy dandy calculator. You can see that I'm in degree mode just because I don't know what 3.14 divided by 4 is, but I do know what 45 degrees is, right? So I'm going to do cosine inverse of cosine of 7 pi divided by 4. And it should say 45. Did I type it wrong? I'm in degree mode. I want to be in degree mode. What went wrong? Overloading the calculator? No, it's supposed to be this order.
No, like do 1 and then just like
No,
have it go
yeah,
under
it's
stuff.
because you need to be
cosine 7 pi over 4.
Well, yeah.
Are you in ready?
Yeah, I'm in degree mode. So this is going to be something ugly. And then cosine inverse of that. What just happened? Okay, something's all kinds of borked. Cosine of 7 pi over 4. Stupid. You know this worked perfectly in first period when I wasn't recording. There. Cosine inverse of that. I don't know why it's doing that. It doesn't make any sense that it would work in radian mode, though. Doesn't make any sense at all. You're crazy. I am now. I am now.
But the answer, like the thing in the first period is radian, that's why.
That's pi over 4.
So it's right in radian.
Right, and I don't know. Honestly, when I did this in first period, it told me 45 degrees. I'm not sure what's going on. Yeah.
When I have something that's degrees, I use degrees. And when I have something that's radians, I use radians.
Right, but again, the point is
It's because 7 pi over 4 is radian.
because the input was radians. Yeah.
If it says like
Oh, you're right. Because when I had it in degree mode, it thought I was doing 7 pi over 4 degrees. Yeah, you're right.
I know I'm right.
Dummy. Okay, big dumb. Smooth brain move. All right. Sine of Tangent inverse of -1. Ooh. This one's different. This one has trig inverse on the inside, right? That means this says sine of theta. So this tangent inverse of -1, whoops, is going to give me some angle. And then I'm going to evaluate sine at that angle. So we're going to talk tangent inverse first. Tangent inverse can only give me outputs in quadrant 1 and -1. The fact that it's negative tells you must be in quadrant -1. Here's 0. Here's -π/2. Tangent is y over x. Like that. And this is actually my theta that we're talking about because it's doing this. I have a y over x. That's how I'm going to get -1. That makes this a 45, 45, 90 triangle. So what does this theta equal? -45 degrees, or -π/4. So the question says, what is sine of -π/4? Not the same thing, but it would be the same triangle. You see, I could go ahead and draw up this triangle if I wanted to, but it's this one right here. This is the triangle that has theta being -π/4. You can redraw it if you'd like to. No. The final answer is what is sine in this triangle. So in this triangle, sine, which is y over r, is -1 over √2. So we're happy when it's trig of trig inverse because you will usually only need to draw one triangle. But when it's the other way around, trig inverse of trig, there's a chance you're going to have to draw two triangles. Like you saw here, I had to draw two triangles. Yes? Yes. So if the outside is an inverse, you're looking for an angle. If the outside is standard trig, you're looking for a ratio. Yes, sir?
I thought you had to like doesn't sine have its own areas where it's positive or negative?
Yeah, sine is positive in quadrant 1 and positive in quadrant 2. But what we did here is we evaluated this and found out that that is -π/4. And then we asked ourselves, what is sine of -π/4? Well, here's -π/4. It's right here. So sine is still in this triangle.
But the negative.
I'm sorry?
Negative. But it's negative.
What's negative?
Like if the answer was if you had a positive pi/4.
If this
Like the first quadrant.
yes, that would be in quadrant 1. But it would not be in quadrant 2. Sine is positive in quadrant 2, but you can't move the triangle. It's not asking for all the different times that it would have been positive. It's saying what right now, where's this one answer? Let's continue to compose. This one says arc cos. I'm not going to write that. I'm going to write cosine inverse. Because the outside is trig inverse, I know that this is going to result in some angle. That's what I know. It's going to result in some angle. So the first thing I'm going to do is I'm going to evaluate the inside. I'm going to figure out what tangent of π/4 is. Well, π/4 is 45 degrees. This is a 45, 45, 90, which is 1, 1, √2. So what is tangent of π/4? It's just 1, because it's y over x. Natalie? Okay. So what we know here is that tangent of π/4 is 1 over 1, which is just 1. that tells us this question is actually asking for cosine inverse of 1. That's going to be our final answer. And you go, well, cosine is x over r. So this is asking you where were x and r equal to each other, because that was the only way that you were going to get 1 over 1. It must be a quadrantal. And the one place that happens, and I'll draw the correct picture this time, just a little bit smaller than normal, is right there. This is where x and r will be the same thing. So the answer is 0. Isn't that fun? Cosine inverse of tangent of pi over 4 equals 0. Yes, sir?
How do you know it's on this side? Or how do you know the pi over 2 and 1 are equal on that side? Not pi over 2,
You mean, how do I know that right here x and r are equal to each other?
Yeah.
Well, this blue thing, imagine it's the radius of a circle, okay? And I could trace it all the way around. The radius is never going to change, correct? Well, here, it doesn't matter. Let's just say that radius was 4. Let's just say the radius is 4. Could we agree that the coordinates right here would be 4, 0? So x has the exact same value as r when you're here. Now, if I was back here, x would be -4, which means cosine would be -1, okay? Yes, sir? No, cosine inverse is how you undo cosine. Secant is the reciprocal of cosine. It's 1 over cosine. Because cosine's an operation. Cosine does not have a value. Okay? Yep.
Why is it equal 0?
Right here?
Yeah. Like, it says like it equals 0, and I don't understand why it equals 0. Because like I understand that land's there. That
Mhm. This is so because inverse trig is always going to give you back an angle.
Yeah.
So I need to know what angle this is. It's 0 degrees.
Okay, I get
0
it.
degrees or 0 radians.
That's so stupid.
Don't worry about it. This is why we're practicing. Tangent inverse of cosine of pi. So let's evaluate cosine of pi. Shh. Let's evaluate cosine of pi. Here's pi. I'm going to put a point right there. Okay, well, cosine is x over r. But this is on the negative x-axis. So this coordinate, if it was going to be a coordinate, would be -x, 0, right? Whatever x is. But the radius can never be negative, so this radius is simply the value of x. So the cosine of this, cosine of pi, x over r, is -x over x. Cosine of pi is -x over x, which has a value of -1. So what the question's asking for is, what is tangent inverse of -1? And we know that our answer will be an angle, because it's trig inverse. So I'm trying to find the angle that produces the value of -1 when I take the tangent. That's what that says. Tangent inverse can only return values in quadrant 1 and -1. The fact that it's negative forces me into quadrant -1. And tangent is y over x. So I'm going to get a -1 in this quadrant as if the y value is -1 and the x value is +1. This is a 1, 1, √2 triangle. What is the size of my reference angle? 45 degrees, but based on where it is, it's -45 degrees, also known as -pi over 4. It's a lot going on. Inverse trig takes practice. Do you feel a little bit more comfortable now in composing inverse trig, or just doing inverse trig and then even composing it with other things? A little bit more comfortable. Okay, well, let's step up the game a little bit. Where is it? There it is, found it. What this is telling you to do is to evaluate tangent inverse first. Tangent inverse can only, so we're gonna work here first. Tangent inverse can only return values quadrant 1 and -1. This must be in quadrant -1. Tangent is y over x. Well, the y's here are negative, so this must be the -1, and this is a positive root 3. Then that's a root 2. I mean, a standard 2, excuse me. All right, well, that's a 30, 60, 90. What is the size of my reference angle here? This is a 30-degree angle. That's its size. But because we're in quadrant -1, it's actually -30 degrees. But you know what? That doesn't really matter. Here's why. The question says, what is cosine squared of that? What that means is evaluate cosine and then square it. 30 degrees is pi over 6, correct? So negative pi over 6. That's what it's telling me to do, because this is negative pi over 6 right here. I could redraw the triangle if I wanted to, but it's this triangle. This is the triangle that's produced with negative pi over 6. See, again, because the trig inverse was on the inside, I don't need a second triangle. All I need to do is evaluate cosine with this triangle and then square my result. Cosine's x over r. Oops, I forgot my exponent. Cosine's x over r. That is root 3 over 2 quantity squared, which is 3 over 4. When trig inverse is on the inside, life is good, because one triangle. Yes, sir? Then two triangles. So if it's trig inverse on the outside with standard trig on the inside, two triangles. Unless of course the original argument is in quadrant 1. As long as the trig ratios are the same, then they cancel out. For example, sine inverse of sine of 30 degrees is 30 degrees because I'm in quadrant 1. As long as they're the same, one, like they're both sine, sine inverse, or cosine, cosine inverse, tangent, tangent inverse, if the original argument is in quadrant 1, then the functions cancel each other out. If it's not in quadrant 1, you're going to have to draw the triangles. By the way, we're not finished yet. Are you sure? Okay, here we go. How about one of the ones where we're finding an algebraic expression? We're going to find an algebraic expression. Tangent inverse of 2x. Well, tangent is y over x, correct? And when okay, let's be really specific here. This is the unknown value x, not the coordinate value x. So for now, how about I say tangent is opposite over adjacent? How's that sound? The adjacent value then is a 1. So I'm going to draw my triangle. My opposite side is a 2x. My adjacent side is a 1. Now, I don't know what that theta is. I do not know what theta that is. But I do know that I could find cosine of this triangle. I could find cosine of this theta. It would be adjacent over hypotenuse, correct? I need to know the length of this hypotenuse then. I have two of the sides. How do I find the third one? Yeah, the Pythagorean theorem. So I'm going to say 1 squared plus, and be really careful here, use parentheses. 2x squared equals, I'll say r squared. Because this is going to give me 1 plus 4x squared equals r squared. Take the square root of both sides. Find out that r is, I don't want to say 1 plus 4x squared. I'm going to say 4x squared plus 1. And yeah, radius is always positive. So this is the square root of 4x squared plus 1. And now you can tell me what cosine of this, by the way, this is theta. You could tell me what cosine of this theta is. It's adjacent over hypotenuse. 1 over the square root of 4x squared plus 1. And since I've written it the way I did, I kind of ran out of space for the next one. So we can either call it there, or I could draw a line and make it fit. We think we're good? All right, awesome.